All right, welcome to the first video. This is the first in a series of videos I'm making on precalculus. Before we get started, just wanted to let you know that I'm new to this, as you can probably tell, making videos. So if you have some constructive criticism for me on the format of these videos, please do let me know in class because I want these videos to work for you guys. The second thing is, I just want to remind you guys that you should all be taking notes, as well as doing the practice problems that I link to in Schoology, right next to the link to this video, because that is what I am checking every day. All right, so let's get started. So this is the first video, which I'm calling Language of Functions. Precalculus is really all about functions. Perhaps functions would be a better name for this class than precalculus. So a lot of functions are going to show up, and as they do show up, we're going to need some basic language just to talk about them. And I also just want to talk about what is a function. So some vocabulary, some language, as well as a couple example problems at the end. All right. So this is my basic diagram of what a function is. This is kind of what I see in my head when I think of the word function. Every single function out there in the world has these three components, okay, which I'm going to label here. So I have two buckets, as you can see, and then some kind of weird steampunky machine in the middle, or at least my best attempt to draw a machine. Okay, so what's on the left here is a bucket, and this is the bucket of inputs. Okay, so this first bucket is what's called the domain. All right, so what is the domain? The domain is a set, and I like to think of a set as a bucket, and it contains all the inputs that can go into this function. Okay, so the rule here in the middle, this machine, is called a rule. Okay, so what does the rule do? It takes an input, something from inside the domain, and it spits out an output, something that belongs here in the bucket on the right. And this bucket on the right, we're going to call the codomain. Okay, now that might not have been the word you were expecting to hear. You might have been expecting to hear the word range. That's a common word from previous classes. And that's a word that we're going to use too, but range and codomain are actually not quite the same thing. Okay, so just want to emphasize that every function has these three things: a domain, a rule, and a codomain. You might also see the letters that I'm using here. X will often stand for something in the domain. F will often stand for our rule, though definitely not always. And Y might stand for something in our codomain. Okay, so these are very common letters, but just keep in mind that these are not always the letters that we use. These letters are prone to change all the time. Based on context, you should be aware what is the domain, what is the rule, and what is the codomain, and what are we calling these things. Okay, all right, so how do we represent functions? So I have three different representations of functions here, and there's basically no representation that is perfect. And that's because that rule in the middle of a function can pretty much be anything. And even the domain and codomain, those are both sets, but those sets can have anything in them. They don't have to have numbers in them, for example. Okay, so let's go through these one at a time, because we're going to see these kinds of representations a lot. So this diagram, if you see these four letters on the left, A, B, C, D, those four letters are what are in the domain bucket for this function on the left. Okay, so what is the domain? It's the set containing the letters A, B, C, and D. Okay, what's the codomain? Well, the codomain is these three symbols, hashtag, or I guess pound sign because I'm kind of old, question mark, and exclamation mark. So those three symbols over on the left are making up the codomain. Okay, now what is the rule? Well, the rule are these arrows in between. And I just want to emphasize, because I think it's really easy to get confused, that the rule doesn't have to be any kind of formula. It doesn't really even have to make sense. The rule basically has one job, which is to take everything in the domain to something in the codomain in a way that is completely unambiguous. Okay, so this function that I have represented here is taking a to question mark, b to question mark, c to pound sign, and d to question mark. Also notice that nothing is going to exclamation mark. That's actually okay. All right, so it's not really a formula, and who knows what this function would be representing, but it's a perfectly good function. All right, so this thing in the middle is going to introduce, I think, a little bit of new notation for us. Okay, so what this is trying to say is that g is a function that takes the set of real numbers to the set of real numbers. Okay, so this letter here, which you may or may not have seen before, is a kind of funny capital R. And that funny capital R is a shorthand way of writing the set of real numbers. Okay, so in this example, the set of real numbers is the domain, and it's also the codomain. And this arrow is just here to tell us that it's going from R to R, and we often call the set of real numbers just R. Okay, so I'm going to just walk through this again. This first line is saying that g is a function that goes from the set of real numbers to the set of real numbers. What is the rule for g? Well, g takes an input x, and it spits out x squared. Okay, so pretty familiar function, even though this may be a new way of seeing it. All right. Okay, so on the right here, I have a graph. This is, I hope, very familiar to us. A graph is another way of representing a function, and there's a lot that's kind of implicit, unsaid, in the way that we write graphs, but should be very familiar, I hope, at this point. Okay. And I also just want to reiterate up here that for this thing in the middle, what I put on the left here is the domain, and what I put on the right here is the codomain. This is the main takeaway from really the last couple of slides. Okay, and this would be a great thing to take notes on. So what is a function? A function has three parts, as we've said: the domain, the bucket on the left, the codomain, the bucket on the right, and the rule that takes everything in the domain to something in the codomain. Okay, so what is the domain? The domain is the set of all allowed inputs. What is the codomain? The codomain is the set of all allowed outputs. Okay, now we get to that word that you were expecting to hear, range. So what's the difference between the range and the codomain? So the codomain is the set of all allowed outputs. However, it might be the case with any particular function that not everything in the codomain is getting mapped to. So the range is the set of everything that is actually getting mapped to by the function. Okay, so you can kind of imagine that the codomain is this bucket over here, and if I take the domain bucket, just kind of imagine that I tilt it and dump it into the rule machine and watch every single possible input get filtered through this function. What's gonna come out is the range, every single actual output. But there might be things in this bucket on the right that are just not getting mapped to, and that's okay. So we can also see some more examples of this over here. So remember this first function on the left with the symbols, right? So I said that the codomain was this set of three symbols, pound sign, question mark, and exclamation mark. Nothing is getting mapped to exclamation mark, however. That's okay. Exclamation mark is still in the codomain, but the range of this function is just the set containing the question mark and the pound sign, because that's what's actually getting mapped to. So for this function on the middle, I'll let you think about what the range of this function would actually be, what is actually getting mapped to by the square function, because it's not all real numbers. Okay. So that's the difference between the range and the codomain. There's a very reasonable question here, which is why this new word codomain? Why talk about it at all? Why have allowed outputs that are not actually getting mapped to? And the best explanation I have for this at the moment is that sometimes with certain functions, it's just really hard to figure out what the range actually is. Whereas the codomain is usually just going to be R. Okay, so it's actually kind of a word for convenience. It lets us talk about a set of outputs without actually having to check that every single output is getting mapped to, because that might be just a pain. Okay, so lastly, I want to cover this line 4 here. The rule assigns everything in the domain, every allowed input in the domain, to one and only one thing in the codomain. Okay, so functions can take lots of different forms. There's lots of different functions out there, but there is one thing they have to satisfy. They have to take everything in the domain to one and only one thing in the codomain. Okay, the last thing I want to do today is a couple of practice problems, specifically about finding the domain of a function. So here's a bit of advice with these videos before I get started. If you're looking at a couple practice problems on the screen and you think you can do those problems without my help, I would strongly encourage you to go ahead and pause the video and just do it. And if you think you can do these two, go ahead and do that now, and we'll just see if your answer agrees with mine. Okay, but if you're stuck or you just don't remember how to do the problem, I'm just going to talk us through it. Okay, so this is two functions, part A and part B. Part A is the rule 1 over x plus 2. Okay, so my advice when you're solving domain problems is to think about what could go wrong. So when you're taking 1 divided by x plus 2, what could go wrong? Well, you could divide by 0. And when are you going to divide by 0? When x is equal to minus 2. So what you could do, if you're not sure how I got that, is you could set up the equation, denominator equal to 0, x plus 2 equals 0, and then solve for x, and you should get x equals minus 2. But for many of you, it's okay if you want to do this in your head. It's okay if you don't want to do this in your head. I don't have any sort of preference about that, and I always say slower is better if you think you're going to make a mistake. Okay, but I'm going to write that down. For part A, x equals minus 2 causes the problem. So if domain is everything where I don't have a problem, domain is all real numbers except minus 2. Okay, so that's the domain of the first function. Second function, think about what could go wrong. That second function is x squared plus the square root of x. The x squared part, that's fine. I can plug in anything into x squared. It just says take the number and multiply it by itself. No problems there. Square root, however, well, I can't take the square root of a negative number. So that means that whatever goes into this function, it has to be positive or 0. So, part B, all real numbers that are greater than or equal to 0. Okay, so note that I just took these sets and I wrote them out in words. I'm not using really any notation. I'm not using the symbols for greater than or equal to or not equal to. You could use those if you want. And for right now, I'm not going to be picky about how you choose to describe a set, but what I am going to be picky about is that we're talking about the same set. So if those sets are not what you ended up with, then take a closer look. Okay, so that was our first video, so I'll see you guys later.